That's the problem. Okay, so let's talk about the consumer surplus. Okay, so let's say this is the function. And let's say we have a particular point here. It could not, it doesn't have to be the equilibrium point. I'm just talking about in general. I want to explain in general what the consumer surplus is, and then we're going to talk about the consumer surplus at the equilibrium point. So we're talking about a consumer surplus in general, and then we'll come back to the consumer surplus at the equilibrium point. Okay, in general. So let's say we have a particular point. Let's say any ordered pair. Just give me any ordered pair.
Q1.
Very good. Let's say 2, 10. Okay, perfect. So, is there any way anyone can tell us this particular area, just this rectangle? What do you think that area of that rectangle is?
20.
Exactly, perfect, because this is 2 and this is 10. So this area must be 2 times 10, which is 20. Excellent. Great. Now, next question. Can anyone, so this is our demand function. Can anyone tell us how to calculate this area? Between this, which is 0, and this, which is 2. Something that we learned in the previous chapter. How would we calculate this area under the graph of d of x between 0 and 2? How do we do that? From chapter 4.
Do you do like the midpoint or left point?
Oh, we're past that. We know techniques now. But you're right. Of course I can do that too, but it will be an approximation. It will not be exact.
Do you get the equations with both lines and then find
The integral from 0 to 2 from d of x dx. This is the area, right? So the area under the graph is the definite integral between 0 and 2 from d of x dx. Would we agree with that?
Yeah.
Good. This piece, just this above, the area above this rectangle, this is the consumer surplus. So we are paying for 2 units. So this is in units, and this is price. So for 2 units, we're paying $10, but we're really getting a little bit extra. Although we only paid $20 for these 2 units, a total of $20, but we are getting some extra values. Maybe insurance, maybe for the product that we are purchasing. So this is our added value, the added value. But how do I determine this? Can anyone tell us what should the formula be for the consumer surplus? Remember, the area in red is this. The area in green is this. How should I write the consumer surplus based on what you see?
You do the area minus 20.
Excellent. The integral from 0 to 2 from d of x dx minus 2 times 10. That's it. Great job. Great job. Okay, so I would like to find a problem right now and just look at, or just create a problem, because I think in the book at this point, they are all for the consumer at the equilibrium point. I just want to stop and just work on one problem so we see how this works. Okay, so let's create a function. Give me a quadratic function. Any quadratic function. This is an example. Any quadratic function that you can think of. Anyone. Okay, 2x squared minus 3x plus 10. Okay, so let's say the interval is between 0 and anyone? 10 is good. Okay. So we are trying to determine the consumer surplus on the interval 0 to 10. And we are going to determine the integral from 0 to 10 from 2x squared minus 3x plus 10 dx minus we have to create a value for 10, and we have to determine a value for 10, right? Because we have to find a point. So I need to find a point between on the interval 0 to 10. Let's find a point. And just stick with that. So let's say when x is 3, but I have to calculate and see how much it is. So the point is 3 comma 2 times 9 minus 9 and plus 10. So this is 19. So this will be from 0 to 3. So the interval from 0 to 3 minus 3 times 19. Minus 3 times 19. This will be the consumer surplus on this interval because that's where we're looking for. We're looking at this function on the interval 0 to 10. I wanted to limit the intervals somewhere, right? Doesn't matter. And we picked the point as 3 comma 19. We have to determine the 19 that fits, that is the function value at 3, right? So I cannot just pick 3 and another number. I have to pick x, I plug it in, and I get 19. So 18 minus 9 is 9, 9 plus 10, 19. So when x is 3, d of x is 19. So the integral from 0 to 3 from 2x squared minus 3x plus 10 dx minus 3 times 19. So from this point on, we know how to solve. If you want me to finish it up, I can. But this was the example that I wanted to show you before we look at the producer surplus and also continue with the consumer surplus and producer surplus at the equilibrium point. Do you want me to finish it up, or is it clear what we're trying to do here? Anyone? Okay, since you're not saying anything.
Solving.
I'm sorry?
Just solving from here, right?
Yeah. Yeah, exactly. So we have 2x to the third. Yeah, let me just write it. Minus 3x squared over 2 plus 10x from 0 to 3. Exactly what we did there, but I didn't have a function there. And minus 3 times 19. So what is that? 7 and 2, 57. And then you get a number. And that is the consumer surplus. Okay? The value added, in other words. Okay, so this is my page 4. So now let's look at the producer surplus. So the function is different because it's this one. So this is the supply function. And let's suppose we have a point. I'm going to use the same point that you came up with, was fine. So 2 comma 10. So this is the 2 comma 10 point, okay? So how do I determine the consumer surplus? Again, you already told me this area. So the red area is 2 times 10, which is 20. But now, this piece, I don't want to jump. I would like you to tell me how we determine this area, the green area. Can anyone tell us the green area? How do I calculate it?
D of x, the derivative of x times d of x, will be on an integral from
The integral from 0 to 2, from 0 to 2, from s of x dx. So we have the red and we have the green. Now, here is the producer surplus. The purple, producer surplus. How do I determine, what do you think? How do I get the producer surplus? And then we're going to talk about the equilibrium. What happens at the equilibrium? Yes, I'm ready.
We do 2 times 10 minus 8.
Exactly, exactly. But just remember, it's from a different function. Awesome. Here is the area under d of x from 0 to 2 minus. The other one is the opposite, but of course from a different function. This is from the supply function, and this is from the demand function. And finally, without further ado, let's talk about what happens exactly at the equilibrium point. So this is the demand. Of course not. This is the supply, and this is the demand. And this is the equilibrium point. So what will happen here? This is the same triangle as the rectangle that we discussed. This is the consumer surplus. And this is the producer surplus. We are ready now to work on any problem you want from page 454 and see how this theoretically is interpreted, and then word problems. So let's practice first with a couple of examples, and then we look at the applications to see where and how we apply this.
What page again?
454. Page 454. Anything from 1 through 14 first. Anything you like to choose, or I will choose the first one if you want. So it says the price is such and such. Find the equilibrium point, the consumer surplus at the equilibrium point, and the producer surplus at the equilibrium point. Which one? Or I will choose. 1, 2, 3. Okay, I will start with 4, and then you choose the next one. We have the demand as x minus 4 squared, and we have the supply as x squared plus 2x plus 6. First, we're asked to find the equilibrium point. How do I find the equilibrium point?
Let them equal to each other.
Awesome. That's exactly what happens. The equilibrium point when everyone is happy. Yes, I know. I just pushed my computer further away from me. Okay. Good. So let's set them equal to each other. So for part A, equilibrium point, we have d of x equals s of x where they intersect. Okay, and now we have x minus 4, everything squared equals x squared plus 2x plus 6. Anyone can give this squared? Anyone? X squared.
Minus 8x.
Very good.
Plus 16.
Awesome. Equals x squared plus 2x plus 6. Nice. I will move this here and move this here. When I move this here, I get negative 10x. Because this was positive, I move it to the other side, I change its sign. It was 16, I move it to the other side, it gets negative 16 plus 6, negative 10. Very nice. X equals 1. So the equilibrium point has x 1. Now it doesn't matter where I plug it in. They have to be the same. So I can say 1 plus 2 plus 6, which is 9, or 1 minus 4, which is negative 3 squared, which is still 9. So the equilibrium point in our graph is 1 comma 9. So 1 comma 9. So now I want to determine the consumer surplus. That value added, consumer surplus, is, remember, is the integral minus this product. The producer surplus will be this product minus a different integral. Same limits of integration, still from 0 to 1, but a different function. So this is how you should remember them together. So this one is from dx, d of x squared, and this one is from s of x, which is x squared plus 2x plus 6. That's all to it. That's all it is to it. So now let's determine them. The first one, so the consumer surplus, the integral from 0 to 1, I will expand it. We have it right there, minus 8x plus 16 dx and minus 9. Have to find the integral. I find that the antiderivative, x cubed over 3 minus 8 x squared over 2 plus 16. Luckily is only from 0 to 1, oops, which is not difficult. I'm starting a new video on this